Guys, this is Miss Miklos, and this is your Chapter 3 test review. And I'm not going to go through a ton of questions, but I'm just going to go through the basics that you definitely need to know in order to be successful on this test. So the first thing I wanted to talk about was graphing, because the first portion of the test has 4 problems where you need to graph. The very first question will be something, here we go, will be something pretty basic like this, y equals 2 to the x. On the test, it'll have an xy chart that you can fill out if you want. It's really just to help you out. I'm not grading it or anything. But I'm going to choose some values like -2, -1, 0, 1, and 2 just to see what the y value would be. I know 2 to the -2nd makes a fraction, so it's 1/4. 2 to the -1st is 1/2. Anything to the 0 power is 1. 2 to the first is 2. 2 to the second power is 4. So if I'm going to go ahead and graph this, okay, I have -2 to the 1/4, -1 to the 1/2, 0 to the first, 1 to the second, 2 to the fourth. My graph would look something like this. Notice my graph did not cross the x-axis. That is very important. That's something I look for. And then there's going to be 4 questions that it will ask you. Okay, and I'm just going to write these off to the right here. The first question, it's going to ask you for the domain. And we know the domain means all the x values. And for every single exponential function, the domain is actually going to be every number. So we write that in interval notation as -infinity to infinity. For the range, okay, we definitely need to look at our graph for the range. We can tell that it definitely is not going to be all the numbers, because if we look past or below the x-axis, our graph is not drawn down there. And so I'm going to say the range is everything from 0 to infinity. Remember that that 0 means that it's getting really close to 0, but 0 actually doesn't work. Okay, remember if 0 did work, we would use a bracket. On all of these graphs, we'll be using parentheses because it'll be something that gets close to but doesn't actually touch. Okay, next up would be the asymptote. Remember, the asymptote is the line that it gets close to but doesn't actually cross. And in this case, we can see that is going to occur at 0. And if you guys think back to our quiz that we took, most of you that missed this problem missed it because you forgot to write this as an equation. It's always a horizontal line on an exponential function, so we're going to write y equals 0. And then the very final thing it's going to ask us is what was the y-intercept. And it might just say intercept, but it does mean y-intercept. And I would accept if you wrote 0, 1, or if you just wrote 1. So one of the 4 graphs will be something simple like either this or 3 to the x, but just kind of something for us to get a basis graph from. Now let's go ahead and look at some of the transformations. So the other ones will be things like y equals 2 to the x minus 2, or y equals 2 and then in the exponent x plus 1, or y equals -2 to the x. So if you guys practice your review worksheet and look at the quiz we took, there's a lot of examples of what those transformations do, and we've talked about that in previous classes. But if we just look at this, we know that this -2 here means that everything in the graph goes down 2. So if you wanted to make a new XY chart because you forgot about the transformation, you could, and that's fine. I'm actually just going to trust our transformation here. Okay, if we think back, previously at -2 we were at 1/4, so I'm going to go down to -1 and 3/4. At -1, we were at -1/2, so I'm going to go down to -1.5. I'm sorry, we were at +1/2. At 0, we are at 1, so I'm going to go down 2 and go to -1. At 1, we were at 2, so I'm going to go down 2 to 0. We didn't go this far, but if you look at 3, 2 cubed, at 2, 2 squared is 4, so it would go down to 2. And I think this is enough for us to go through. So some things that we notice is everything just moved down 2 spots. And once again, if I forget what all the transformations are like, I can always make an XY chart to help me out. So our domain, once again, is going from -infinity to infinity. Our range this time is a little bit different, and we might need to think about what our asymptote would look like. It looks like our asymptote is going to be at the line I'm drawing right now, because that appears to be where it's not going to cross. And remember, if I want to double check, I can always substitute in more x values to check this. If you guys want, you can bring a scientific calculator for this portion. You will not be able to use your graphing calculator on this part, but I think we should all be okay without a calculator at all. So since that looks like y equals -2, our range is from -2 to infinity. Our asymptote is at y equals -2, and our y-intercept is at 0, -1. Notice my asymptote and my y-intercept were both -2 or 2 down from what our original graph looked like. So that's going to be the first part of the test. Excuse me. The second part of the test is going to be some more just like logarithmic stuff. It'll be really similar to the types of quizzes that we've taken so far. So I want to start off with something basic like 4 squared equals 16. There are a few problems on the test where all we need to do is change forms. We know 4 squared equals 16 is an exponential form. If I want to change this into logarithmic form, I would write log base 4 of 16 is equal to 2. Remember, a logarithm is really just an exponent, so that's why my exponent is what the logarithm is equal to. I know that my base of my exponent, so we call 4 a base, is my base of my logarithm. So that's a skill you guys just really need to practice. Okay, it doesn't get any harder than that. It's really just memorizing where those go. But I think those are some easy points on the test. Okay, working the other way. Log base 12 of b equals 3. This time it's in logarithmic form. I need to change it into exponential form. So my base is 12, so I'm going to write 12. My logarithm is equal to 3, so that becomes my exponent equals b. And that would be our answer. So I think those are points that are really easy to get. You just need to spend some time memorizing that. Okay, next concept is another one that can be pretty straightforward, and this is dealing with change of base. Okay, we know that the only 2 bases we can put into our calculator are log base 10, which is our common logarithm, or just log, and log base e, which is our natural logarithm, ln. So if I have anything else, like here I have log base 3 of 30, we have to use our change of base with either log or ln, it does not matter. I know whatever this number is going to go in the numerator, and whatever is in the base stays on the bottom. The most important thing when we put this into our calculator is to remember this parenthesis right here. If I mess up that parenthesis, it messes up my answer. So when I put this into my calculator, I get 3.096. Sorry, pressed the wrong button there. Okay, next concept, expanding and condensing. Remember, we have 3 different rules. We have our power property, where exponents become coefficients, or coefficients become exponents. It works both ways. We also have our our product property, where if things are multiplied together, we can split them up using addition. Our quotient property is our third property, and that is if we have division, we can split it up using subtraction. So if we look at this first problem here, log base 5 of x cubed divided by y squared, this is telling us to expand. So the first thing I'm going to look for is if we have any multiplication or division, and I do. So I'm going to write log base 5 of x cubed. Since it is division, I'm writing minus log base 5 of y squared. And now what I'm going to do, I need to look and see, do we have any exponents? And I can see that we do. So I'm going to have to bring those out in front. And I get 3 log base 5 of x minus 2 log base 5 of y. And that would be our final answer. That's actually all we can do with that. Okay, so first thing we look for, multiplication, division. Then we move our exponents to be our coefficients. If we're condensing, okay, that is when we are taking multiple logarithms and turning them into a single logarithm. So we actually work backwards. This time I look for coefficients first, and I make those into exponents. Now something like y to the 1/3 is kind of strange. In fact, we've learned fractional exponents are actually radicals. We've worked in class with like x to the 1/2 is root x, y to the 1/3, that means that my denominator there, that 3, becomes my index number. So it becomes ln of the cube root of y. This numerator right here, the 1, is actually the exponent of 1. I'm sorry, the exponent of y. Since it's 1, I don't have to write it. After I change my coefficients into exponents, now I need to look and see if we have any addition that we can change into multiplication or any subtraction that we can change into division. So in this case, I say we have addition. So I'm going to make this ln of x squared times the cube root of y. Once again, these problems are really just us memorizing the properties. The ones that are on the test are pretty similar in difficulty to these two problems. So if you feel pretty good using the properties on these, you'll be in good shape. Okay, next thing I want to talk about is simplifying. If we have something like log base 2 of 1/8, there's two different ways we could do it. Some of you might just prefer to do log of 1/8 divided by log of 2. That is using our change of base property. The other thing I can do is change this into a logarithm. Or I'm sorry, change it from a logarithm into exponential form. So I can make this 2 to the x equals 1/8. Then my goal would be to make 1/8 have an exponent of 2. I know 2 to the -3rd power is 1/8. Since I have this same base, I can say those exponents are equal, so x is equal to -3. If you went ahead and did log of 1/8 divided by log of 2 in your calculator, you would also get -3. I do not care which way you do it, so you should use whatever method is easiest for you. Okay, next problem. We actually have 3 ways in which we could solve this. If you guys think back before we learned how to use our calculator, actually I'm going to pause and put this on the second half of this video. As I was saying before, there's actually 3 ways we could go about doing this. The first method is to go ahead and change the bases so that they are the same. I know that I can write 25 as 5 squared to the 2x plus 1/2 power, and I can write 125 as 5 cubed. To be honest, if I recognize this, I actually think this is probably the easiest way to solve this. So I have 5 to the 4x plus 1, because I have to distribute that 2, equals 5 to the 3x. And then I can go about and say 4x plus 1 equals 3x. So 1 is equal to negative x, and x is equal to negative 1. So that would be one method which we could use to solve that problem. Second method I could use. In this case, since I have exponents on both sides, I could go ahead and take a log of both sides. This is one we actually would not change into a logarithm, so I take it back. There's only two ways we could do this. I could do log of 25 to the 2x plus 1/2 equals log of 125 to the x. Now, I know exponents can go out in front, so I have 2x plus 1/2 times log of 25 equals x times log of 125. And at this point, I could just do log of 25 in my calculator, do log of 125, multiply log 25, distribute that to the 2x and the 1/2, make log of 125 the coefficient of x, and then I could just make that a simple algebraic equation where I'm trying to solve for x. So either way we could go ahead and do it, does not matter. Okay, now something like 5 to the x equals 8. We have a few of these on our test. This is one, I cannot solve this by making both sides the same base, because there's no way I can write 8 as 5, there's no way I can write 5 as 8, and there's not another base that I could think that I can write both of those in. So this is the one in our notes that we said we have two different ways. The first method, I can use the idea of changing something from exponential form to logarithmic form. So the first way I could go about doing this is making this log base 5 of 8 equals x. So that's just from changing forms. And then I could go ahead and use our change of base. So log of 8 divided by log of 5, which is actually 1.292. Now some of you guys did it that way. The other way we could do it, we said we could take a log of both sides. So I have log of 5 to the x equals log of x. I can move the x out in front. And then to get x all by itself, I would divide both sides by log of 5. And you guys will notice that that is the exact same equation that we did over here. So I end up getting 1.292 as my answer either way. I do not care what method you use whatever you think is easiest. There are a decent amount of the problems on the test that are simple solving problems like that. Just a reminder, and we talked about this a lot in class last time, whenever I have an exponent that has a variable, that is when I need to change forms and use a logarithm. Okay, so let's do one that is a little bit tougher. So 10 to the 2x minus 6 equals 146. The problem here is I have this negative 6. That's not being taken to a power. So the very first thing I'm going to do is add it to both sides. So I get 152. Now I can either just take a log of both sides or change it into exponential form like I modeled on the previous problem. I'm going to go ahead and take a log of both sides. So I get log of 10 to the 2x equals log of 152. Now something kind of special happens here with log of 10. I know log means that our base is 10. We learned whenever these numbers are the same, it's just equal to 1. So I have 2x is equal to log of 152. So in my calculator, I can do log of 152 divided by 2, and I get 1.091. Okay, final thing I'm going to go through here are two different word problems. I'm going to model an example of an easier word problem and model a tougher word problem. And you guys will have both types on your test today, or test tomorrow. So our first one here, Find the number of years for a $1,000 investment to double at a 12% interest rate. So, y equals AE to the BT. Let's just review what these things mean. Y is the amount at time t. A is the initial amount. B is the rate. And t is the time. Remember, E is a number. So, at any point in time, I should only have one thing we don't know. If there are two things we don't know, we need to have two equations, and that'll be what we're going through in the tougher problems. So, to be honest, okay, 100 could be our A, but this idea of doubling, there's a shortcut that we've talked about. The other thing that would be important here is 12%. If you wrote 200 equals 100 e to the 0.12t, I want you to notice that I changed percent to a decimal. That would be great. The other thing we could do, though, whenever we see this word double, I know I can just start by saying 2 equals e to the bt. Because if something's doubling, the amount divided by the initial will be equal to 2. If it says it's tripling, I would divide it. It would be equal to 3. If we were dealing with half-life or something like that, I would divide it and it would be 1/2 or whatever that amount is. At this point, I can just solve this logarithm or this exponential equation. Since my exponent has a variable, I need to change it into a logarithm. And I'm actually going to take an ln of both sides. And some of you might be wondering why I'm going to do ln, and the reason is ln of e is equal to 1. So I actually just have ln of 2 equals 0.12t. So I'm dividing both sides by 0.12. And when I put that into my calculator, I get 5.9 years equals t. So there will be probably 3 or 4 of these basic word problems that are just one step. Sometimes I might be finding y, sometimes I'm finding the rate, sometimes I'm finding the time, sometimes I'm finding the initial investment. But what makes them a little bit easier is there's only one step. There will be 2 or 3 of these tougher problems like this one, and I actually took this one from our word problem worksheet. And it says C14 is known to have a half-life of 5,730 years. An ancient palm tree contains only 35% as much carbon as a similar piece of a contemporary tree. How old is the tree to the nearest year? Okay, whenever they give us this little hint, use the rate to a certain amount, that tells me I don't have the rate. So the very first thing I'm going to have to do is actually find the rate. Since it's half-life, I'm going to do 1/2 equals E. I don't know the rate, but we know the time is 5,730. And then, oops, I shouldn't write T, I should write B. So I'm going to take an ln of both sides. So I can move my exponent out in front, and I know ln of E is equal to 1. So I would divide both sides by 5,730. And I get a really long decimal, but it does tell us to use our rate to 5 places behind the decimal point. So I get the rate is negative 0.00012. So I do need to round to whatever they're telling me. If I don't, I'm not going to get the same answer. Okay, I chose to go through this problem because I think it can be a little confusing, because then it says only 35% as much is in a similar contemporary tree. That 35% is just like when it says half-life or double. So I'm going to put 0.35 equals E. This time I actually know the rate, but I do not know the time. So if they tell you that a certain percentage of a chemical or an element exists, I know that I'm going to be using that as a decimal. That would be the y divided by the a. Okay, so once again, I'm going to go ahead and take an ln of both sides. So I have ln of 0.35 equals negative 0.00012 t. So I would have to divide both sides. And when I put this into my calculator, I get 8749 years, because it did tell me to round to the nearest year. Now that seems like a pretty accurate year. That's not a weird answer. If I got a negative answer, I would definitely think that's weird. Okay, but I just want to stress on our word problems, make sure your answer makes sense. Take your time, set it up. You guys should have plenty of time on the test. Just make sure you guys review these basic concepts, and you should do great.